The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents.
Hello, my name is James. Welcome back to Workbench Wednesdays, where we review hardware for your electronics workbench. This video continues our series on soldering tools from Weller. We already covered tasks like upgrading your soldering station, soldering through-hole components, and how to rework surface mount boards. This episode is a little bit different because it is going to be more of a lecture than the previous videos. One topic Weller asked me to cover was air quality and proper fume extraction when soldering. Here's a picture to explain why. Weller ran a test for 90 minutes where they placed a filter inside of a hose. This was the result. Looks pretty nasty, doesn't it? Most of us have probably soldered for a cumulative total of 90 minutes, which means if the smoke went into your face, that's what your lungs are filtering. So I have some cool information to share with you on different solders, the details about flux types, and finally a review of these fume handlers so you can decide which is right for you. First up, let's address lead-free solder. Back in the 2000s, something called RoHS or ROS became a common word for everyone in the electronics industry. While it is known as the lead-free directive, the restriction of hazardous substances covers a large number of other materials as well. RoHS is why lead-free solder became so popular. The primary component in solder is tin. In the past, lead was used to reduce its melting point. Lead-free solder uses different metals for the same reason. These two spools of solder may look about the same. One is from Duratool and the other is from Weller. However, their metal composition is very different. The Duratool spool has 63% tin and 37% lead, while the Weller is known as SAC or SAC. SAC is mostly tin but includes silver and copper as well. You might see numbers like SAC 305, SAC 105, and SAC 307. These numbers identify the amount of silver and copper in the alloy. Those metals help reduce the melting point, but not as well as lead. Speaking of melting points, when I solder with 60/40 lead solder, I find that it starts melting easily around 250 degrees Celsius, while lead-free solder, like this SAC 305, needs to be closer to 325. Of course, the temperature will depend on the exact solder you're using, the type of tip on your iron, and the workpiece. When it comes to fumes, many people are concerned about the lead content in the fumes they breathe, and I think that's a valid concern. Personally, I'm not that certain that solder fumes contain lead. However, I would rather err on the side of caution and assume that it does. That said, I do know there is something just as important, if not more important, to consider, and that is the flux. All solder that is used for electronics contains some form of flux. In fact, if you have solder with no flux, it is probably meant for plumbing and not electronics. Flux does a few things that help make good solder joints. First, it spreads itself across the metal surfaces as it gets hot. Then it attacks oils on those surfaces while attempting to move stuff like dirt out of the way. Most importantly, it breaks down the oxide layers on the metal surfaces so that there is good contact with the molten solder. What you might not know is that flux is acidic. In fact, it is acidic enough that it roughens the metal surface just a little bit, breaking up the surface tension of the molten solder, which allows it to flow better and is why good solder joints wick up a wire. Soldering flux is a huge topic. For some people, it's just enough to know that by adding flux, their soldering gets easier. I'm not going to cover all of the details related to it, but I do want to cover some basics so that when you look at a product, you know what's in it. Next, let's talk about this nearly magic substance. Flux is made up of a base, an activator, and a solvent. That base can be a rosin, an organic or inorganic material, with rosin being the most popular and best recognized. Fun fact, rosin is made up of pine tree sap. You'll see it listed as gum resin in material safety datasheets. Organic materials are more aggressive, but usually need to be cleaned after being used. Lastly, inorganic is the most aggressive or powerful flux. Despite the name, the activator does not activate the flux. Instead, it works along with it. Activators improve the cleaning and deoxidizing process. Back to rosin, it comes in three forms: rosin, rosin mildly activated, and rosin activated. RMA and RA contain an additional activator while R does not. Last is the solvent used to help clean up the flux residue. That's when you'll see something listed as no clean or water soluble. By the way, when you see a flux listed as no clean, it does not mean that there will be no residue left behind. It means any residue remaining is inert. Visually, you may still want to clean that residue away. An excellent document to check out is the IPC standard JSTD004. It describes flux designators which characterize these types. Let's put all of this technical information into some examples. First up is this flux from Weller. Its datasheet says that it is halogen-free and that a flux cleaner is necessary. We can verify this with the DIN or ISO chart using the number 1.1.3.A. This designation tells us that it is a rosin flux type without a halide activator that comes in a liquid form. By the way, 1.1.3.A lines up to ROH0 on the IPC chart. Next, let's go to the leaded solder. It has RA listed on its label, which means it is rosin activated. Its datasheet says it is high activity, non-corrosive, and is classified as ROM1. The RO confirms it is a rosin type, and the M1 suggests that it leaves moderate residue behind while using halides. Even though this one is called no clean, I'm going to keep cleaning it. Halide activators are aggressive and could cause corrosion later on, even though the datasheet says that it won't. Regarding the M1 classification, I totally get that. When tinning tips at high temperature, I could see a ton of flux activity happening with this solder. Last, I have this spool of lead-free solder from Weller. Its label only says M1. We have to look at the material data safety sheet to see its hazardous ingredients include something called caliphony, which is another word for rosin. Two quick notes. First, resin, rosin, and now apparently caliphony do tend to be interchangeable when talking about flux. Second, if the flux designation is L0 or M1, it is very likely to be rosin-based, so we didn't really need to look at the MSDS to find out its composition. In the next video, I'm going to cover solder iron tips and how to prolong their life, but I wanted to mention something here. Flux is an acid. The more aggressive the acid, the faster a tip wears out. Weller recommends using their lead-free solder because its flux is designed to be effective at lead-free temperatures while prolonging the life of a tip. As a quick preview, check out these two tips. The tip on the left has been using Weller's lead-free solder, while the other tip has been using a more aggressive flux. Notice the buildup on the base of the tip. That's from the flux residue. Like I said, we'll cover more of that in the next video. Now, with words like acid, halides, aggressive, and residue, it should come as no surprise that when it comes to solder fumes, flux is what I worry about. Which brings us to our next topic. How do we keep those fumes out of our face and our lungs? This unit is called a smoke absorber, and it's the first device I ever used for clearing the air. Let's go see how well it works. For my test setup, I have a Weller WXP120 soldering iron and some large diameter lead-free solder. I'm just shoving it into the hot tip to see what happens with the smoke. The absorber does a good job capturing and filtering it. There's no smoke coming out of the other side, and there's a small amount of smell, but it's not too bad. These really aren't that complicated of a device. In fact, it's just a cone, an activated carbon filter, and an AC fan. While the construction is simple, it is effective. So, how does it compare to something like the Zero Smog EL? Well, let's watch the same test. I'm using the same solder and iron as before, and as you can see, the smoke is getting collected by the hose quite well. In fact, if we watch closely, this design creates a unique air pattern that captures as much smoke as a smoke absorber, even though its opening is much smaller. And this brings us to our first in the differences. While effective, the smoke absorber takes up a relatively large amount of bench space. Now, before you say, James, the Zero Smog EL is clearly larger. Well, yes, it is larger. However, the filter section is normally under your workbench. The fume collector is relatively small and easy to position. Let me brace you for something. The cost factor between these two units is like 6 to 7 times. To understand why, let's open up the Zero Smog. I have already removed the hose. There are 2 latches to remove the cover, which simply lifts off. Then I see my first surprise. Let me grab another camera. As you can see, there's a piece of solder that got sucked up along with the smoke. The HEPA M5 particulate filter caught it. These units do support 2 ports, but I'm only using 1. The main filter is a HEPA H13 and combines both a submicron filter along with an activated carbon filter which reduces odor. The bottom piece is just a blower. As I put this together, I decided to rotate the pre-filter so that I can get longer life out of it. As you can see, the filter and blower are more significant than the smoke absorber. The Zero Smog EL also has variable speed control, a remote switch option, and can be used on multiple benches at the same time. So which do you choose? Well, first, let me say any extractor is better than none. If you only solder on an occasional basis and you have room for the absorber on your work area, then it's a decent option. However, if you solder on a regular basis or in a professional environment, then a full filter system is preferred. For more information on the Weller Zero Smog EL, check the link in the show notes. There is information on the products, additional health information from Weller, and links to 2 other reviews. One is from the Ben Heck Show, and the other is a written review by me for an Element 14 road test. If you have questions, come find me on Element 14. I would love to hear your experiences with fume extractors. For now, it is time for me to get back to my workbench.